point, it's probably best for you to not watch this video right away, but try to answer this on your own if you can. And if you get stuck, that's when you actually watch the video, okay? All right, so this is number 9. I'm going to copy the problem. 4 minus 6x over 24 divided by 2 minus 3x over 8. So this is division. So that means keep it, change it, flip it, right? So let's do that first. So I'm going to keep the first fraction. Okay, so I'm gonna do 4 minus 6x over 24 times, I'm gonna flip this second one, 8 over 2 minus 3x. Okay, so now that we just have a multiplication, so that means we have two fractions, and so we need to just factor out both numerators and both denominators. All right, let's try the top one. You can factor out the 2, so you have 2 minus 3x there. 24 is 24 can be factored out as 2 times 2 times 2 times 3. Okay, now if you cannot factor that, if you're confused how I came up with that, well, you can just do this too. Okay, 24 is 6 times 4, and 6 is 2 times 3, and 4 is 2 times 2. So you have 1, 2, you have 3 twos and 1 3. So you can do that as well, especially for bigger numbers. All right, times 8. 8 can be factored out as 2 times 2 times 2. And then 2 minus 3x, there's really no common factor, so you just copy it, 2 minus 3x. But since it's a binomial, you put it inside parentheses. Okay, time to cancel. This 2 and that 2. Okay, that's 1. This 2x minus 3 and that 2x minus 3. Next, this 2 and that 2. Next would be this 2 and that 2. So try not to crisscross, like cancel here and then cancel on the other side. Just move from left to right so they're not crisscrossing. It's easier for you to keep track. Okay, is there anything else? Well, nothing really. What's left on the numerator? You only have that left. So that's 2. And in the denominator, you have that. Okay. Now, if you don't have anything left, that means there's a 1 in there. Okay. Okay, so that is number 9. Now, let's move on and do number 10. Okay. Now, I just want to make a point that this and that they're the same, pretty much, right? Now, sometimes you don't really see it this way. This problem can also be rewritten as this: y minus 3 over 4y minus 7. That's the same problem here. But instead of this division sign, they would put it in a big bar and then copy the other one, 1 minus 3 over 20. This and this original problem, they are the same, okay, just written differently. This one just looks a little bit more scary, but this long bar is the same as that division sign. Okay, all right, so let's copy the problem. Y minus 3 over 4 y minus 7 divided by y minus 3 over 20. Okay, so the first thing, because this is division, is keep it, change it, flip it. I'm gonna keep the first one, the first fraction, y minus 3 over 4 y minus 7, and then I'm gonna flip the second one and put 20 on top, and then y minus 3. Okay, all right, so now it's time to factor numerators and denominators. Y minus 3 cannot be factored out, so I'm just gonna keep it as y minus 3 and put that inside parentheses. 4 and y minus 7 can be factored out as 2 times 2, and then y minus 7 cannot be factored out anymore. Okay, so now we're moving on to 20. So that's going to be 2 times 2 times 5. And then y minus 3 cannot be factored out, so it'll just be y minus 3 and put that inside a parenthesis. Okay, so let's cancel. So this is what I was talking about, not to be like all over the place in cancellation. Like this 2, you don't need to be canceling it with that 2, and then this 2 can be canceled out with that 2. So it's sometimes it's okay for now, but if you have so many numbers, it could get very confusing. So my suggestion would just be go from left to right. Okay, so you can start with x minus y minus 3. Do you have a y minus 3? Yes, you do. So you go this and that. Next, you have a 2. This 2 can be canceled out with that 2. And then that 2 can be canceled out with that 2. Is there anything else? You have only 5 left on top and there's no 5 in the denominator. So therefore, you're done with cancellation. You only have 5 over y minus 7 left. Okay. Alrighty. So let's do number 11. What is the so you, before you start trying to solve everything, just look at the problem first. Like this one here, oh, this is division, keep it, change and flip it. This is division, keep it, change and flip it. This is multiplication, no keep it, change and flip it, just multiply. Okay, so in the division, after you keep it, change and flip it, you factor. In the multiplication, you just write out factor. Okay, now also the first factor here is 2x. It's not really a fraction, so you cannot just write it as a fraction. So instead of writing 2x, you write 2x over 1 times 1 over 14x. So this is your problem, right? And so now since we only have multiplication, basically that means you just need to multiply all the numerators and all the denominators. So 2x can be factored with 2 times x. 1 is just 1. All right, and then 1 on top of the second fraction is just 1. 14x can be factored as 2 times 7 times, actually I'm going to write it, that's fine, 2 times 7 times x, okay? And so now anything in the numerator can cancel out with anything in the denominator. So this 2 and that 2, okay? And then this x and that x. And technically, the one will also cancel. Not that it really makes a difference. Okay. So in the numerator, if you cancel out, say, let's just say you cancel out the one, which is fine, really. If you look at the numerator, nothing is left. Okay. So you cannot just really leave the numerator hanging in there. Okay. You can do that with the denominator, but not the you can do it with the denominator, but not the numerator. So there's nothing left in the numerator. You just put one, and then in the denominator you have 7 left. Okay, all right, so let's do number 12. Now this is addition. So the difference between addition and multiplication, addition is okay, so multiplication and division, they are the same pretty much. Addition and subtraction, they are the same pretty much. Okay, these two have more work because you need to have the same denominator first, and then add or subtract, and then do a cancellation. This two is pretty much just do a cancellation. Okay, so that's why they're easier. Okay, so number 12. So you have 11 over 12 plus 7 over 4x. Okay, so we will prepare our two bars. So that means we need to factor out the denominators. Okay, so 12 is 2 times 3 times 2. Okay, and then 4x is 2 times 2 times x, and we just copy the numerators. Okay, and so this is the time we will put the dots, right? So this first two, 1 2 here, 1 2 here, that means they're paired. Okay, the 3, well, there's no other 3, so this is my 2 dots. This second 2, that will be my 4 dot, 1 2 3 4, because there's another 2 in here. Okay, so every single time there is a pair and the second one, they count as one. And then, of course, I have the X. They will be just by itself. I'm just going to make it like a check mark because I don't want to draw 5 dots. Okay. All right. So now that we have all our denominators, so you may have to, if you want, you can stop first and look at it and see if you understand what I'm trying to do. So this 2 and that 2, they're paired. The 3 doesn't have a pair, so it gets its own number of dots. There's a second set of 2s, that's another set of dot. And the x is another set of dots, okay? So now let's fish out all the common denominators. So you have 2, so you have this, okay? I'm going to write that. And then you have that by itself, times 3. You have this, so times 2. And then you have that. So those are all. So you have 1, 2, did I miss 3 dots? I missed 3 dots, right? So the x could have been 3 dots. Okay. So I have 1 dot, 2 dots, 4 dots. I didn't have 3 dots. Okay. So I should have 3 dots. But that's okay. It's just a way to differentiate them. Okay, so there's nothing else. So now I'm just gonna copy this. 2 times 3 times 2 times x. Okay, and I'm gonna copy the numerator. Okay, so it's time to circle now. Okay, so you have 2, 3, 2 here, and 11. So this is like the old fraction. And then this one right here, so the 2, 7, 2x, this is just like the old fraction, right? 2, 2x, 7. So therefore, there's an extra 3. That means the top one you need to multiply by 3. Okay? Alrighty. Okay, so now you have, oh, did I miss something? I must have missed something, huh? Because that x right there, you need to multiply this by x, right? Okay. So now you multiply the top, you have 11x, not x11, 11x over 2 times 3 times 2 times x plus 3 times 7, you have 21 over 2 times 3 times 2 times x. We're not really multiplying the denominator yet because we just want to make sure that there's nothing else that will cancel out. Okay. Now 11x, well, now they have the same denominator, so you can write 2 times 3 times 2 times x together, and then you can do 11x plus 21 because you can't really cancel them out. You can't really combine them, so you just write them as is. Now, is there a common factor between 11x and 21? Not really, so therefore we will just write them back. Okay, over, and it's time to multiply this because there's obviously nothing that will cancel them out, so that's 12x. So this one should be your answer. Let's see if that is in there. uh okay, I see it. All right. Okay, so this is a good problem for you to try, so try this one on your own. All right, let's move on to number 13. So this is again in an addition. Okay, so now we need to just prepare our bars. 99x is 99 times x. Or you can write it as 9 times 11 plus x. You can do that too. 9 times 11, that's 99 times x. The x is just x. And then you have 1, you have 1. Okay? All right, so let's do the dots now. 9 is 1, there's no more 9. This is 2 dots. And then the x is 3 dots. One, two, three. They're both x's. Okay, so now let's copy all your copy all the common denominators. So you have a 9, you have an 11, you have an x. So that's all you have to write here as well. And so now copy the 1, copy the 1 here. And now we're ready to circle. Okay, so this is exactly the same as the top one, so there's really nothing you can do with that. But on the second one, this one right here is the same as that. So that would mean you have to multiply the top with 9 times 11 because these two does not get, they're not the same as the one on top. Okay. All right, so now we can copy this 1 over 9 times 11 times x plus 9 times 11 is 99 over 9 times 11 times x. So now you have the same denominator. You can just copy them. So you'd have 9 times 11 times x. And then, but you can add 1 and 99 now because they're pretty much the same, like terms. So you have 100. Now, what are the factors of 100? Let's try if we can cancel with 9 and 11. Factors of 100 are 2 times 50. 50 is 2 times 25. 25 is 5 times 5. So that's 100. 9 times 11 times x. Is there anything that will factor? No, not really. So since there's nothing that will factor, then that means you have to just multiply them all back. So that's going to be 100 over 99x. That would be your answer. Okay, last number on this page. All right, so that's another addition here. So you have 2x, 3x minus 6 plus 3x, x minus 2. Okay, so the first part you need to just find the factors of the denominator. So you have 3 and x minus 1 or x minus 2. I can't even divide now. And then the top one, the second one is x minus 2. Since it's by itself, it cannot be factored, just put it in parentheses. Let's copy the numerators, 2x and 3x. Because they're just monomials, so you don't really have to put them in parentheses. So now it's ready to isolate all the different types of denominators. So 3 is 1 dot, 2x, that's 2 dots. Okay? So next part is we will write all the unique denominators. So you have 3 and x minus 2. That's all we have. So you have 3 and x minus 2. You just copy. And then now we copy the numerators. You have 2x here and then 3x. Okay, so now we circle. So that is exactly the same as that. So that means there's nothing to multiply here. But then the one on top, this is it. So therefore, you need to multiply the top by 3. Okay? Take note of that, 3. Okay, so now let's simplify. So you have 3, not 3. So you have 2x over 3x minus 2 plus, you can multiply that, you have 9x over 3x minus 2. So now you have the same denominators, you can just rewrite them together. So you have 3x minus 2, and then the top, well, they're like terms, so you can add them. So you have 11x. Okay, so let's factor out the 11x to see if there's something else that will cancel. So you have 11 times x, and then 3x minus 2. Well, can you cancel anything? There's really nothing, so you don't, that means you don't really have to factor it because there's really no thing that will cancel. So therefore your answer will just be 11x over that. But since your denominators are all multiplied out, so you probably need to multiply this one out. So you have 3x minus 6. So 11x, 3x minus 6. Again, my advice is do this on your own, and then if you get stuck, then that's when you'll watch the video. Okay.